Hello, everyone. Today we are talking about mathematical knowledge domain and philosophy of mathematics. So what we're looking at here is the concept of understanding what it means to be a mathematics teacher and what entails being a mathematics teacher. So first and foremost, we talk about mathematics teacher belief. That teacher mathematical belief refers to those belief systems held by the teacher on the teaching and learning of mathematics. So beliefs are said to originate from previous traditional learning experience, mainly during schooling. Once acquired, teachers' beliefs are eventually produced in a classroom's instructions. So basically, what we are trying to say here is that what you believe as a teacher originates from how you were taught and your experience as well as a student or as a learner. So if, for example, when you were still a learner, the mathematics teacher used to beat you a lot. So it becomes easier for you to have a um, negative thing towards mathematics or negative attitude towards mathematics because you associate mathematics and the beating. So hence also they say that educational environments foster and reinforce the development of traditional instructional beliefs. So how you experience the mathematics will determine your belief, and that's how you're going to associate it. So each teacher holds a particular belief system comprising of a wide range of beliefs about learners, teachers, and teaching and learning, schooling, resources, knowledge, and curriculum. And these beliefs act as a filter through which teachers make their decision rather than just relying on their pedagogical knowledge of curriculum guidelines. So before you apply your method of teaching, everything lies from the one concept of what are your beliefs as a teacher. And those beliefs will determine how you're going to teach. And if you feel that learners are just a vessel that needs to be imparted with knowledge, what you normally do is you decided to just impart knowledge on them. So this means that you got in the classroom, you don't even have interaction and things like those because you believe that learners are just sponges. They must just suck knowledge out of you. And how you believe will determine how you're going to teach. So teachers teach the way they have been taught, basically, and that is the ultimate role. So one of the questions I can ask myself is, do you agree with this statement? Yourself as you're going to be a teacher, do you think you're going to teach the way you were taught? And if that is the case, then that should be my role now is to make it a point that now, as I'm going to be your teacher, how I'm teaching you should be so much of a good thing that you will be a better teacher based on how you have seen me teach. And again, this is just the beliefs. And one can also say, no, that is not the case. It's not always the case. But teachers teach the way they have been taught. Okay, so educational system may act as a vehicle to produce traditional mathematical belief. Teacher seems to pass on these beliefs in subtle ways in school classroom. So I'll give an example. When we teach mathematics, for example, when we talk about subtraction of whole numbers, we use that method of a vertical column method. And then in that method, we will say you go borrow next door. And then if you go to somebody else who's not using the borrow, you feel that no, how you were taught, you also teach your kids by means of using the word borrow. Whether it is acceptable or not, you make it work so that your kids can, because that's how you understood. And you felt that the way you understood was better and quicker. And you feel that everybody must apply or learn this knowledge so that it can be able to equip them the same way it has equipped you. So large numbers of teachers still perceive mathematics in traditional, rather as a progressive terms, that is, as a discipline with prior rules and procedures. So teachers believe that in maths, there are these rules that must be followed. And if you don't follow them, everything is wrong, right? And others feel of no, learners must discover for themselves. And once they discover for themselves, then they will create knowledge of mathematics. And this contributes into how they normally learn the mathematics. So now, then the question is now, what is your personal understanding of mathematical knowledge for teaching? So if that is the beliefs and the beliefs foster how we teach, then the question is it important for the teacher to go to a teaching college or to go to a university and study to be a teacher? Because then if you already know mathematics, what's the point of coming to study to be a teacher? Like, for example, someone who's getting a distinction in mathematics, in high school, for example, do you think that person should still go and study to be a teacher because already they know the maths? Then the question is, what is the mathematics knowledge for teaching? So what I want to look at is, instead of carrying on that particular belief that knowing the maths is good enough, let's look at what is it that the mathematics teacher needs to know in order to be an effective mathematics teacher. And that part is what we normally look at, and we understand how mathematics is taught. So there's a paper, or there's a study done by Deborah Ball, where he talks about the specialized mathematics content knowledge, whether what makes being a mathematics teacher special, or what makes the knowledge of mathematics teaching special. So he talks about two things, which is the subject matter knowledge and the pedagogical content knowledge. And all these are derived from the work of Schulman, 1986, where he talked about 6 aspects that makes a mathematics teacher, and that makes one to be able to teach mathematics effectively. So the first one is the common content knowledge. The common content knowledge refers to the mathematical knowledge that is commonly known as and used by individuals across various professions, not just teachers. For example, we all know that 15 plus 10 is 25. You don't need to be a teacher to know that. Anybody can know that. That's just, and you do know how to calculate it. If I were to ask you, how did you calculate that? You will know and you'll have an answer. So that's just a common knowledge. Everybody knows it. And again, if you are a doctor and you know this, it's not special about being mathematics. It's just common mathematics. So when you talk about common content knowledge, is that what we're trying to say here is that a teacher must know the mathematics. You must know the answers. You must know the mathematics you're going to teach and have correct answers. Okay. Then you have the horizontal content knowledge. So which refers to teachers' understanding of how mathematics concepts are connected across different topics. And what we mean by this, for example, you already know that if I'm teaching fractions connect with decimals, and it also connect with percentage. And you know the differences and similarity between the two, and how all these three can be gelled and work together. And that is horizontal content knowledge. And part of this is when you know that what you are teaching now, how does this link with what you're going to teach in future? So this is what we're talking about when we talk about horizontal content knowledge, is understanding how different mathematical ideas relate at the same level, help students make meaningful connection and apply knowledge in different contexts. And also teacher use horizontal content knowledge to design and integrate multiple mathematics concept so that you can be able to understand how learners are well taught. Then you have your specialized content knowledge. This refers to the deep mathematical knowledge that is unique to teaching. It goes beyond knowing how to solve, anticipate student misconception, and represent ideas in multiple ways to support learning. So if you look at this particular aspect, you know that mathematics itself has learners the way in which they learn. And then when you talk about this special content knowledge, we're talking about anticipating student thinking. You know that, okay, if you are doing, for example, exponents, you know that learners will normally just add exponents without knowing why we are adding them. So how do you normally rectify this? And sometimes you know that learners, when we do fractions, for example, fractions with the same denominator, we're supposed to just add the numerators. Learners sometimes they add denominators as well. And because you know these, you tend to start creating mathematics. So knowing these parts of information is what we call specialized content knowledge, right? You use multiple representation as you teach, because then now you know that, okay, I know learners might not get it at first. They need diagram for me to explain it. And how am I going to explain it using the diagram? If they don't understand the diagram, I'll bring in the storyline so that they will understand better. And all this is part of specialized content knowledge, the knowledge that makes you a mathematics teacher, how to use the representation, how to justify the procedures. For example, you know that if I use this method learners find it difficult, I must use this one. And I can't use this one because this method, when I use it, it makes learners to have issues with 1, 2, 3, right? That's your specialized mathematics content knowledge. Okay. Then you have the knowledge of the content and the students. So it's a type of pedagogical content knowledge that involves understanding both mathematical content and how students think about it. So here we look at how do students learn the mathematics? And we're saying that that's what the knowledge that the teacher should know, right? So you should be able to anticipate student error, predicting the mistakes students might make based on their prior knowledge. So basically, you can see that, okay, learners normally make this type of mistakes. And this is what we mean by the knowledge of the content. So you know what students are capable of doing and what they're not capable of doing. So for example, you know that learners at this particular age, if this is not taught, they won't be able to understand this. So I need to teach this first so that they can understand that, right? So adapting the teaching method as well. You teach it in such a way that you are suiting this particular learners. So for example, if you go to a place whereby you find that the learners are very bright, and if learners are very bright, you know that you can't just use any example. You must come with bright examples that will challenge them, right? That's what we mean by the knowledge of the content and the student. So you are teaching a lesson that is geared for the learners, right? And not just focusing on the curriculum. Okay. Then you have the knowledge of the content of the curriculum. So this one is the knowledge that refers to teachers' understanding of the structure, goals, and progression of the mathematics curriculum. So what we're saying here is knowing what to teach, when to teach it, and how to teach it. Okay? So when you talk about this, we're talking about knowing national, regional mathematical curriculum guidelines. So knowing the KEPS document, what does KEPS saying? So that you don't find yourself teaching grade 8 stuff in grade 7 stuff, or teaching grade 7 stuff to the grade 8. So you must know how the curriculum has been designed and designated. You know where to teach, how to teach, and how to focus things, and how to align things. And when you choose the textbook, you choose the textbooks that can align with the content document or the KEPS document. And that's when you say you have the knowledge of the content of the curriculum. So comparing to someone who's just teaching, you can understand this by the concept of the fact that someone who's just a teacher or who just knows the mathematics, they don't have to know the curriculum document. They just know the maths that they already know. And that's when you understand that there is an importance in knowing the content and the curriculum. Okay, so at first, as I already said, teachers must know the subject they teach. Teachers who do not themselves know a subject well are not likely to have knowledge they need to help students learn this content. So students normally, for them to learn, they need to learn from someone who know what they're doing. So just knowing the subject well may not be sufficient for teaching. So knowing the mathematics is not good enough. There is more to learning mathematics than just knowing the math. And that is why my argument is based on this particular concept that teachers knowing the mathematics is not enough. If you have any question, just send me an email. I'll be happy to answer your questions. Thank you very much. Have a lovely day.